All right, so this is lesson 2.8, and we're going to continue our proofs, but talking now more with angles and writing proofs that involve congruent and right angles. So remember that just like segments, we can have angle addition. We can add angle plus angle is equal to its whole. So left plus right equals whole. Just like segments, we can use that for angles. So what I definitely recommend again is that we label our picture as we go so that we can kind of follow our thinking, but also help if we need help to use our picture. So let's go ahead and fill in first just what we know comes first, and that's our given. Go ahead and fill in the last statement, what we're trying to prove. And then let's go ahead and label our picture that this is 23 degrees. This is a right angle, so it's 90 degrees. And then angle ABC total, I'm going to kind of put it on the outside, is 131 degrees. Okay, so where are we going to go from there? Well, since we're talking about angles and we're going to look for a part of it, we need to show angle addition. Just like if it were a segment, we need to show segment addition. So angle 1 plus angle 2 plus angle 3, and you can use your letters to kind of help you with that. The other thing we need to do is we need to explain that a right angle actually has a measure, and that's 90. So right angle is 90, angle 2 is 90 by definition of a right angle. Now we can go ahead and do our angle addition postulate. Angle 1 plus angle 2 plus angle 3 is equal to 131 degrees. Then we can go ahead and substitute, and actually I already substituted 131 in there, which technically we should say is angle ABC here instead of 131, and then plug it in, substitute it in as well. So this one should actually be angle ABC. Then we substitute the value in for each part that we know. And then we can go ahead and simplify or substitution again to combine those. Then how are we going to get measure of angle 3 alone? We're going to subtract. So subtraction property to get what we're trying to prove there. All right, let's take a look at the next one. So go ahead and fill in what you know, where we start, where we're going to end. All right, so there's our given. Now, where do we go from there? Angle addition postulate, right? We want to go ahead and talk about what plus what equals what. So, measure of angle 1 plus measure of angle 2 is equal to QPS because we're talking about QPS here. And then we'll talk about TPR as well in just a little bit. I split up my angle addition postulate. So TPR, let's talk about what plus what equals that. So that's going to be 2 and 3 are going to give you the TPR. Now we can go ahead and technically we should have gone from congruence to equals because we're going to now substitute this in for this and this and for this, and we're using equals. So we really should have a definition of congruence in there before we do that, but I missed that step. So replacing this in here and these two in for that one, substitution. And then we can go ahead and subtract the same angle from both sides to get 1 and 2. And then if it is equals, then it is congruent, and that's definition of congruence. All right, and we've kind of talked about these a little bit, but definitions, so if we have complementary, supplementary, then we can go either way. If something's complementary, then we can say those two angles add up to 90. If something's supplementary, 180, and vice versa. If they say it adds up to 180, we can say supplementary. If it adds up to 90, we can say definition of complementary, then those two angles add up to that. So sum is 90 and 180. All right, so let's go ahead and start with this next one. Go ahead and fill in what you know, which is your given, and then what you're trying to prove at the end. So that should be given. Now let's talk about what does this mean, because where are we going to go from there? Well, we've got supplementary. What does that mean? That means that this 1 plus 2 is equal to 180, and 2 plus 3 is equal to 180 by definition of supplementary angles. Then we can go ahead and put, since they both equal 180, where can we go from there? Transitive or substitution, that this is equal to this. And then look, they both have the same thing on both sides. Could we get rid of those? Because we're trying to get 1 and 2 congruent. So let's go ahead and subtract. And then going from equals to congruent, we would have definition of congruent. Two other theorems that we want to talk about here. We've got congruent supplements. That's just saying that if angles are supplementary to the same angle, then they're congruent. Okay, it works for complementary too. If they are complementary to the same, then they are congruent. So let's go ahead and write that out. Congruent complements here is what we're going to refer to down here, but let's finish this one. There we go. Congruent supplements theorem. So if 5 and 6 are supplementary, and 7 and 8 are supplementary, or 7 and 6 are, these are both supplementary to 6. So what does that mean? 5 and 7 are congruent. That's the congruent supplements theorem. So if they're both supplementary to the same angle, then they are congruent. Now, here's the congruent complements theorem. It's just changing it to 90 instead of the 180, but it's the same thing. If they are both complementary to the same angle, which they are, they're both complementary 1, then 4 and 2 are congruent. All right, another one is the linear pair theorem. So basically these are kind of like definitions in a sense here. So if we have two angles that form a linear pair, then they're supplementary. Because linear pair we know forms a line, lines are 180, lines are supplementary. So it's kind of just putting all of those pieces and connections together. So angle 1 and 2 form a linear pair, then they are supplementary. All right, so let's go ahead and take a look at our next proof. So with kind of all of those things that we've talked about so far in mind, let's take a look at this next one. Where are we going to start? What are we going to end with? Always start filling in the given, putting what we're trying to prove at the end, and then given for our reason for the given. We don't know our reason for that last statement, though, until we get to it. So let's start with those. Now, I do have my givens split up on this one. That's something that's already filled in for you. So if something is a linear pair, what can we say about them? We just talked about it in the previous page, that they are then supplementary by the linear pair theorem. So if something's a linear pair, it's supplementary. This next one you already had, it was given to you. So then we can go ahead and jump to our end statement, because if they are both supplementary to the same angle, then they are supplementary, which these are 2 and 2 here. They're both 1 and 3 are supplementary to 2. So that means they're congruent by the congruent supplements theorem. So that's kind of using two of the ones that we've just talked about on the previous page. If they're both supplementary to the same angle, then they are congruent. Okay, all vertical angles are congruent. It's the vertical angles theorem. Vertical angles theorem. So all vertical angles, we can automatically say they're congruent. So let's take a look at this next one. So we're going to fill in what's given. And a big hint, we just talked about vertical angles being congruent. So do we see any vertical angles? Yeah, 1 and 2 and 3 and 4. So what do we know about vertical angles? They're congruent. So we can say that 1 and 2 are congruent and 3 and 4 are congruent by vertical angles theorem. All right, now we know that 1 and 4 are congruent. So we can go ahead and plug 2 in for 1 and 3 in for 4 to get what we're trying to prove, which would just be substitution, property of equality. All right, all right angles we've got here form some 90 degrees, so we've got a couple different theorems. So perpendicular lines intersect to form 4 right angles. So if we know something's perpendicular, then we know all those angles are right angles. All right angles are congruent, and perpendicular lines form congruent adjacent angles. We also know that two angles are congruent and supplementary, then each angle is a right angle. So think about that one. If they're the same and they add up to 180, well then they must be right angles, right? And then two congruent angles form a line, then they're right angles. Very similar to that one. But again, this one, two congruent angles forming a linear pair, which we know linear pairs are supplementary, but we've got to kind of write both, then they're also right angles. All right, let's continue on. We got just a couple more proofs to practice with here. All right, go ahead and fill in what you know. So hopefully you've filled in 1, both the statement and the reason, and then also number 8, your statement, which is what you are trying to prove. All right, let's go. If we start with something that is congruent, more than likely we're probably going to jump to, and it already has it for us, definition of congruent. So if it's congruent, it is equal. Now it has 1 and blank are supplementary, and 2 and blank are supplementary. So that is, they're forming a line, if we look at our picture. So that is, if they're forming a line, they are a linear pair, and linear pairs are supplementary by the linear pair theorem. So it's 1 and 4, and it's 2 and 3. So it kind of guides you on that one. Now, what's the definition of supplementary? If they're supplementary, what do they add up to? 180 degrees. Now, if these are both equal to 180, we're probably going to set them equal to each other, either the substitution or transitive property. Now we can go ahead and we want to maybe try and get something to get rid of this and this to get 1 and 2, because that's our goal. Well, we know that 3 and 4 are equal, so we could replace this angle 3 with a 4 by substitution. Now they have the same thing on both sides, which we can then get rid of with subtraction. So 1 is equal to 2, and we could change that into congruence by definition of congruent segment angles in this case, or just definition of congruence. All right, last one here. Start with what's given, angle WXY, and I have my givens split up. 1 and 4 are kind of my givens, but you could put them all together and just have 5 steps. That works too. Now we're going to go from right angle to what? Something's a right angle. You could do that next and then angle addition, or you could do, I have angle addition right here because I was like, well, let's start with the addition part here, that 2 plus 3 is going to add up to WXY. Then I said, oh yeah, WXY, if it's a right angle, it has to be 90, so we can replace it right in there as opposed to just saying that angle's 90. So do some definition of right angle along with kind of a little bit of substitution. Now we can go ahead and put our other given, and then we can go ahead and substitute in 1 in for 2, because we know that 3 is equal to 1, so putting that in for 3. And then we can go ahead and jump to our last statement of, if they are 90, then they are complementary by the definition of complementary.